Hello and welcome back to my Twitch stream about building a 2D game, multiplayer in Flutter. I think this is episode number 21. Let me double check here. I think I'm uploading a few right now, showing up as deleted. Yeah, I think it's 21. And in this episode, we'll actually focus on gRPC. So gRPC, what is gRPC first of all? So gRPC is remote procedure call, but done by Google. So that's, I think, what the G stands for. So remote procedure calls are nothing else but the client basically executing a method that then actually runs on the server and then receiving back a result. And gRPC is basically the implementation by Google, which sits on top of HTTP2, and it provides a way to basically define the messages that we're sending back and forth. And it also provides a way to define services, and we're going to look into that in more detail like this, and basically methods that these services will have. And for a lot of languages, including Dart, we can actually generate these services and then use them in our code. So they have different ways of communicating. One would be we just basically send a message and get one response back. Another one is we send a message and we say we want actually not just one response, but we want to be streamed. So let's say, I don't know, keep me updated about the weather. So it would basically send a stream of weather data. We also can send a stream from the client, like here, and just return one response from the server and keep streaming to the server. What we're actually most interested in is the bi-directional stream. So bi-directional means that basically clients can connect to the server one time, and basically they have something like a socket. So basically we have, let me get my pen. So we have something like this, right? It's a socket. Kind of round, right? And then you have the client here, and then the server on this side, and then the client basically will send data this way, and the server sends data back this way. So in our case, basically we would send kind of like, you know, if I press the key, I'm not really good at yeah, this is supposed to say key. So we're pressing a key, right? We're sending that to the server. The server then will go and update the world, right? And then it'll send us back the game model that changed. And the thing is, though, there might be other clients that are also causing the game model to update, right? If some other client presses a key, then obviously that needs to be taken into consideration. That player will move, or maybe the player will shoot, so we'll have more bullets. So then the server basically sends these updated game models to all the clients, right? But the idea is that we keep this connection open, which makes for really fast back and forth. Like we need to basically minimize the latency, basically the time from which something changes in the world until the client knows about it. We need to keep that as low as possible. And with a persistent connection like this, that is the best way to do this. So here we have more. Kind of here we explain the bidirectional streaming. I'm going to put this into the channel. So if you want to read about this, also when I publish these videos, I am including resources. So all these links will be as part of the resources. So there are certain details here. But what we'll do for now, we'll walk through a quick start just to see how this could work. So we do a quick start. And the quick start is actually, I started already looking through this a little bit to see if this is a good thing to do. And basically, it basically shows us a really simple example, and then we'll change some things about it to learn how to basically generate some things and how this all works. Once we walked our way through the quick start, we'll go ahead and actually do a small little spike to see how basically this could apply to our server. Like we'll do some messages, or we do some messages that are somewhat more similar to what we are going to need in our game. So what I already did is, and I'm going to, if you want to go along, so this is only a link to the quick start we're doing. So in case someone wants to walk along, and so this one I already did, this part here, and this one we will need most likely later on when we, actually now when you have the link, you probably can just follow here and copy this here. I don't need to copy this all in the chat. This one is basically a Pro2C, which basically I think is to generate the Dart code from the protobuf definitions. And we'll see what all that is in a second. And then I basically cloned this repository, which has an example in it. And I went to the example hello world directory, run pubget. Pubget basically is kind of like Flutter pubget, except it's for Dart only. And that gets the dependencies. And that's where we are basically. And then explains how to start the client and the server. So here we have that hello world application open. We have client and server. I already have scripts to run those. If you're using IntelliJ, the way I created those is you can right click and say run server, or you can just have a shortcut to do the same thing. So if you run the server, we should stop everything. So if you run the server, let's just run the client first and see what happens if it doesn't find the server. So it says, right, I cannot connect to the server. Can see it has a socket connection, and it's actually a gRPC error, and it's trying to connect on this port. It gives us some information. Okay, so it looks like we have to start the server first. So let's start the server. Now we started the server. The server is telling us which port is listening on. So let's restart the client. And now the client is able to send a message to the server and get something back. So let's look a little bit through the code here to get a better idea of what we're dealing with basically. So we're not going to look at this yet, what it extends, but we have a greeter service, and the greeter service basically has a function, say hello. And so we start the server up, we're saying serve on this port, we just print out that we are doing that. There's no mention of say hello in here, because that is actually an override. So we are overriding a say hello method. Well, how does the greeter service get that say hello method? Well, we'll look at that in a second. Client is a similar thing, where basically we have main, and here we create a greeter client, and we're going to look at like how did we get that greeter client? Where did that come from? And then basically we just send a we say hello, we call a method here, and that's basically the remote procedure call, right? So we're treating this method as if it actually exists on the client, but what it really does, it actually goes and it makes a request to the server and then returns the result. And then we'll shut down the channel. Basically, here's the client channel, which basically the greeter client uses to connect. Okay. And now let's go back to the walkthrough. So one thing we have here, we have basically a service greeter, right? And that defines a method, right? And that's basically our greeter service, right? It defines a say hello method, right? And if you look in the protos, this is what we're actually looking at. Let me actually install the plugin to make that look nicer. Let's see what this one is. Yeah, I wonder which one we actually need, or if we need both. We'll install both. If they somehow conflict, we can always remove one. So, okay, in the meantime, we can go back here. So we define a greeter service. That's our service. That's the server, basically. And we say it has an RPC method called say hello, which takes as input a hello request and returns a hello reply. And in the same file, we define what that is. So it's a hello request is a message and has a name property. And we have to put this one here it's kind of like an enum, right? It's the first one. And why is this important? Because protobuf is a binary format, so it needs to know which order things are appearing in your message. So it can basically, instead of like parsing it like JSON, it can basically jump in the buffer. So for instance, that may go beyond the scope of what we need to understand. But you know, if let's say you have 4 integers and we know all of them are 32 bits or 64 bits. Well, if we try to go to the second one, we can just jump across the first integer, basically 32 whatever, and read from there. So we don't have to actually like parse through the message. We can just basically seek into it, so to speak, which is much faster. And then we have a hello reply, which also has a message. And that's basically all that is. So let's look at this. So I might have to... Why is this still looking ugly? I might have to restart my IDE. So let's quit and restart this to hopefully get this the syntax out to make this look a little nicer, and also get some help when we are writing this. Okay, so it doesn't want to get back up. Okay, let's see. Let's just start from here. Okay, nice. So hopefully this will look a little better now, a proto file. Yes, it does, right? We have some syntax highlighting in here now. Don't worry about this yet. This is more related if you're using this in a Java project. We are not using it in a Java project. I am not sure if this even would apply to a if you're using this with Dart. Okay, so what they want us to do. So now you can see the let's see if we can jump to things. So yeah, we can actually now jump to things. This is now a nice way of editing proto files. And what this tutorial wants us to do, it wants us to create another message, say hello again, with the same data types, right? So let's just do that. So basically, it is basically doing this. Okay, so it has the same signature as say hello, and just say hello again. And now the main part of this tutorial here, I think, is to learn how to regenerate then the outputs. But before we do that, let's actually look at what would be generated. So we have this proto. And I'm just looking if maybe there's a way where it allows us to automatically rerun just got reconnected. OBS is just telling me I just reconnected. So just to, in case people missed what just happened, we're just basically looking through the generated code that gets basically generated from the proto above definitions here, right? So here we got the greeter service base, and we can see here that we have a say hello method. And we don't have to understand all these details, but this is basically enabling these method calls, right? So when we in our greeter in our server here, right, when we say hello, we override this. This is the one that basically this generated class calls our method, and basically then returns the result, and then basically that's getting passed into here, which basically handles all the gRPC stuff for us, all the socket communication, all this stuff connecting. All this is basically done for us, which is nice. So, but we basically changed the prototype, well, the proto buff. I don't know how you call those. These are basically types that you define in proto format. And what we need to do now is we need to go ahead and regenerate. So we only changed this. Let's check out this one. I think I might have fixed something in there. Not important. So now this is the diff that we have right now. And we basically need to see how to regenerate our code. So it says here we do proto-C, and we're just going to copy this and then look through it. So we say proto-C, and this is where basically the output is supposed to go. And so basically this would be probably the format. We want gRPC format, and this is a folder where it's supposed to go. And then the input is a proto format, and it is in this folder. So let's see what happens here. So proto C not found. Okay. That is rather odd because I just installed it. Let me just see. Basically what we were doing before I started this, let me just make sure I do this. I don't think I would need that though. Yeah, it's still not found, right? Where did it get installed? Let's just do this again. So I wonder if this tells us where it installs us to. So this is basically a binary that we need in order to regenerate our proto file, our Dart files from the proto file. So okay, so there's a proto C gen Dart. So maybe maybe that's what got generated. So where is this? Proto C gen Dart. So that's actually what got generated. I'm going to see if this is a binary file or not. Let's see. If it's a binary file, it will look okay. It looks like that's what we maybe are supposed to use. So let's see. Proto C. Maybe the instructions are not up to date. So what we're going to do is we're just going to try and do this. So see if that works. Otherwise, otherwise we may have a problem here. Oh, here we go. Proto C gen dot is installed in home cache bin. But then the weird thing is that it tells us to run proto C. Huh. Okay. So this one never finishes. Okay. Yes, we have that installed. It must be in your path. It is in my path. I'm pretty sure it is. It was. We found it. Maybe we're missing a step. Where does this proto C come from? Maybe we need to first install proto C, right? So maybe that's something else actually. So we're basically just trying to run a plugin, but it's maybe used by something else. If anyone has an idea, just please post in the channel. Proto C. I mean, here's how you have the same thing, right? For Go, it's a very similar. You get this, and then suddenly this proto C thing is supposed to be there. Where does this proto C come from? I'm gonna try something. I'm gonna see if maybe we can install it via brew. That will save us in the moment. Because I'm thinking that maybe. Okay, so it doesn't found this. It finds all kind of other things. Well, let's actually try if we can maybe install the Dart one with brew. Maybe that works better. I have no idea. I'm confused at the moment because this is not working like this. This is not working like this. This walkthrough explains. Oh, ha! Missing this. Okay, here we actually have now the so we need to get the latest release of this and install it. So what we need is so what does it say? It's ready to install. It's download precompiled for operating system. Version OS zip from here. Unzip this file. Update the environment to include the Pro-C binary file. Okay, so we need to sum up. So this is not like really super nicely done. Where are the? So this is the OS X file. I think this is the only one. So we install that one. So I wonder where we want to put this. Let's unzip it for now. Let's see what's in there. Okay, so we got this is the one we want. So I'm going to rename this just to Pro-C. Okay, so for now I'm going to set export this folder into the path. I mean, obviously I'm not going to leave it in downloads, but just for now, that's what I'll do. So let's go to downloads, and we'll just get the path. Okay, and then in the bin, that's what we need to export. So I'm going to do this little thing where I'm just printing the entire directory. Copy that. Now we go back to where we were before, and I'm just going to export path equals this thing and the current path. All right, and now we should be able to do what we were trying to do before. So this one should now work. Okay, all right, cool. So we got it working. So I was missing one important step, was to install Pro-C, and it was kind of, when I skimmed through this, I kind of just jumped right here. Okay. Now we should have some difference here. So now we can actually see, and we can actually look through this in here with a git diff. Let me pull this out. Make this into a window. So we can see here what changed, right? So basically what was added, a hello again was added inside the, I think that would be the client, and then also in the server. So that's all it did. It just regenerated everything. We didn't add any types. So it just regenerated, it just added some methods, right? So now what we should be able to do, well, let's follow the tutorial here. Now we should be able to call this from our function, from our server, right? So now now greeter server is most likely we are missing an override. Okay, that's good. So we're missing one override here. Okay. And I would say we'll just copy this from here, most likely, and say hello again. Okay. And why is it complaining? Oh, hello reply cannot be returned. Interesting. But it wants a hello reply. Oh, it needs to be async. Okay. Okay. So so now we have another extra method here. Nice. Now, most likely we can call from the client, but let's just not cheat here or like get ahead of ourselves. Let's look at what we need to do. So yeah, we did this, hello again. And then in the client, we're also going to, also do invoke this. So let's go to the client. So the client is sending hello, and then basically we say response again, right? And we're gonna say hello again, and we're going to say hello response again. So now if we run the server and then the client, this should work. So okay, yeah, so we got greeter, we've received the hello world and received the hello world again, and the server was just behaving perfectly. So that was pretty easy. What I want to do though is I want to look through some example code that has streams in it, because that's most likely what we are going to do. We are not going to go one message at a time. That's going to be too slow for our purposes. Because if we do one message at a time, that means the connection will be open. We'll do the entire handshake of TCP. I think that's what is still underlying HTTP2. I know that there are some optimizations in HTTP2, mainly server push, but I doubt that will help too much in this case. We need fast communication back and forth. We want a socket that stays open where we can just like send messages, right? So let's look at the project where we're in. Maybe we have an example here that has stream. Doesn't seem like it. So what we're going to look at, we're going to try to see if we can find an example for streams. So let's see. gRPC. Well, let's just say stream. So there's some Java code example. Yeah, okay. Let's look for gRPC stream example. Okay. So it says the route. Okay, so we got. Oh, okay, actually, the route one seems to be streaming. Okay, so let's go into the route guide here. That's the one they have here, and actually make sure we got all the dependencies, and then we'll try to look through this and try to understand this. So let's close this project first. So you kind of just see it there, right? That was simple enough. Once you figure out how to install Proto-C, of course. So we have a server and a client again. So let's just first try. Usually with these samples, I usually first try if it works at all, and then I go ahead and look into it, because a lot of times things don't work and you start wasting a lot of time with something that is maybe not supposed to work. Okay, so it looks like we're getting a stream of data here. Do you see that? So we made a request and then we got a stream of data. So let's see a little bit what's going on. Let's first look at the protos. That's probably interesting to look at. So what do we have here? So proto is actually this IDL. I kind of like it. It's very easy to see what kind of services we have, right? So we have a route guide, which has a get feature that just returns a one-time feature, right? But here we have list features, and instead of returning a huge array, it actually streams us the features. And then we have a route chat, which allows us to basically sending a route node and getting back a stream of route nodes. I don't know what a route node is, so we can jump here. So basically we can say, so that's just kind of going back and forth. Hey, I'm here and this is why I'm here. And then the server says, well, you are here and that's why you're here, I guess. Okay, But that's interesting. We should definitely focus on that when we look through the server code and client code. And then basically here we just have a bunch of these messages defined. And it reads very nicely. Right? Almost the comments get a little bit in the way of like seeing the structure of this, but it's a very concise way of expressing these services in the message that they basically send. So here I guess we have just like, yeah, we just have like some JSON data that's just using an example. Not important. Important obviously is that this data gets transformed into a protobuf format before it gets sent, right? So this is a generate stuff. We probably don't want to look at that. Let's look at the server first. So here there are a bunch of methods here, helper methods that the server uses. So here we have list features, for instance. List features basically is yielding. So we have this async star, right? This is denotes that this is a generator function. It generates return values, right? It yields more than just one return value. But the thing is that the idea here is when list features is called, and when we're yielding the first feature, it already streams that feature to the client. It doesn't wait until we returned all the features, right? So that way the client can already see them as they come in. So, you know, let's just say you had a list of whatever, like, I guess those are locations or features. You can already start showing them in the web page, even though you don't have all of them yet. So record route is basically, let's see what this is. So, okay, so this is basically saying that if I'm, you know, I think this is like for runner applications or maybe for walking around, and you want to record where you're walking. So you get send a stream of points, which is basically a point got generated, right? And so that's the interesting thing here, that we are no longer, as programmers, we are no longer declaring our data types in Dart. We are declaring our data types in this proto format. And then the where's point? The Dart code for that will be generated from. So we have the message point here, and that got generated into this highly unreadable Dart. But you can still see here we got the core int and we got latitude, and so you can see there are a bunch of helper methods around it that allow us to easily work with this. And they add here some from JSON, right? So if we had a JSON, we can easily create that. Here we have copy with. So all these kind of really useful helper methods are generated for us, and we don't have to do it. So now, the client will send points basically, and then what we are doing here. So basically what's happening is, I have not seen this constraint actually. I'm going to look up what that actually does exactly. That's something interesting. Yeah, the thing is like what I actually want, I want really this to be there. Let's see. That's really interesting. So await for, it's not here. Yeah, so it seems to be rare enough to not even come up in these examples. But what I'm thinking is that this basically says the request is a stream, right? It's a stream of points. So we are awaiting one at a time. So instead, if you don't put the await here, most likely will complain. Yes, it says the you cannot loop over a stream. But what you can do, you can await each value in the stream and then execute the loop body. So basically, it's the same thing as iterating over a list, except we are iterating every time an item comes in, right, from the stream. So this code will run every time the client pushes another point into the socket, right? So so we start the timer, right? This is basically, okay, we're walking, and now we're mapping a bunch of things. And then when we're done, okay, this is interesting. So it looks like this loop completes whenever the stream completes, right? So we keep doing this loop. Just one thing to notice, so we are obviously not getting stuck in this loop. At least I hope not. Otherwise, that would mean our server is basically can't do anything else. So like as we know in Node.js, for instance, in JavaScript, if you have an await, it doesn't really wait here. It just basically remembers that position, goes and does other thing. And whenever something more comes in, it will return here. And I think that's how it works in Dart as well. And so when we have all the points, we stop the route, and then basically we calculate a route summary. And yeah, we calculate a route summary and then return that. So that's interesting how that works. So if we look at the client, and we look at, what was it again called? Route summary, right? So let's look at the client. Route summary. Okay, so we're not using that, actually. Yeah, we're not getting the summary. Or we are. Oh, it's called record route. Okay, so yeah, I think that's correct. So let's close this one. Let's go to the server. It's called record route. Yes. Okay. So this is the way it looks from the client. So basically, we say record this route, and by the way, this is my stream. Wow, this is pretty awesome, right? It looks like we're actually just calling a function, but what has to happen, the stream somehow has to be converted into protobuf and all this stuff, and all that is happening for us under the hood. So here we're saying generate a route of 10 items, and we basically generate a random route. And what we'll do, we're simulating here that it takes us a while to generate the each point, because we are supposedly walking, right? So we basically delay this a little bit, also randomly, but at a minimum 200 milliseconds, and then we basically we get this back. So let's just see if we actually saw this in the output. Visiting point. So I think this is it. Yeah. So visiting point, finishes with 10 points, and then it calculates us how many meters we walked and how long it took. So that's that was that part. Okay, so that's interesting. So that's basically how we could, from our game, we could send basically send keyboard strokes like that. Right. Okay. Now the next thing. Let's look at some more. So I want to get to the ones that actually are bi-directional, where we have two streams. So again, this is streaming from the server, this is streaming from the client, and then this is streaming in both ways. So that's what I want to look at. What's interesting is record route here is spelled with an upper R, but then when it gets generated, it has a lower R, if you notice that. Or where's the server here? Right, record route has a lower R. So I guess that's part of the how things get generated. So the route chat, right, basically what it is like, okay, I'm going to get a stream of requests from the client, and then I'm yielding, with the generator function, I'm yielding nodes. So we're basically converting, so the request has a node in it. So let's just tell us the type here. So it's a route node. Okay, yeah, it's obviously a stream of route nodes that are coming back. So we're getting route nodes and we're returning route nodes. And the route node is generated here. And now this is where things get a little bit annoying. Now, if I jump here, it looks like that. So what I need to do instead, I need to look here, what is a route node? It's basically just a point and a message. Okay. So we're collecting the route nodes and we're just sending it back. Oh no, hold on. No, we're not. We're basically sending all the nodes that we received. So let's just say we had multiple clients. They're all sending us nodes. We're basically broadcasting to everyone, as far as I know. And then we're adding this. Obviously now the same client sending multiple nodes will get their old nodes sent back to them, but that's fine. So that basically, in our case, that would be the game model, right? We would be streaming out the game model. So we would be taking a client actions, right? and we stream back. That's pretty much all we will be doing. We just basically have a function like this that has a stream of client messages, like inputs, what happened on the client, and streams back what does the game look like now? Like, what's our current game model? So okay, that is pretty cool. So let's look actually how that is implemented on the client. So the route chat here. So we are sending a route node with a message. Oh, here we're creating a bunch of nodes. Okay, fine. And then we're just sending them again, delayed. And so those are the outgoing nodes. And every time so the call is basically a stream. If we put a type annotation here, we're going to see that. So we have a response stream of route node. And then basically we just print them out. You got message so and so. So let's see that. We should actually have seen that. Sending message. It also only got one message. Now that is odd. It seems like maybe the client is quitting. But why would it be quitting before it got all the nodes? Maybe it's just not staying alive if it doesn't receive anything. Let's add a few more messages and see what happens here. All right. So let's restart the client. Server should still be running. Actually, the server now should have already more messages. Okay, so now that's interesting. So we got we got first message, we got the fourth message, and that must have been something that we sent before. So now we got more messages. We're sending a sixth message. We never got, so it seems like the client is logging off basically before the server responds. So if we actually restart this server, and then run the client again, now we're not getting quite as many messages because the server doesn't have them yet. So let's see that. So yeah, you can see that now we didn't get quite as many. But we got the first, second, third. We got the first again, the fourth. So we have to make sure that we figure that out in detail, because we cannot lose any messages, and also they have to be ordered, right? But as far as I understand, the gRPC bi-directional is ordered. Streaming order. The client reads gRPC guarantees ordering for this. For bi-directional, the order of messages in each stream is preserved. So that's important, right? So that's what we need. Okay, so at this point, I think we're almost ready to start with our own project. What we'll do, we'll leave this open. Don't need the run window, but we'll leave this project open in order to refer to it whenever we run into problems, which we most likely will. What I'm going to do though is I want to see if maybe I can find a plugin that allows us to run Proto-C somehow. Re-Proto-C. Well, I want to kind of see what this actually is. I think we already have this installed. Let's see what we already have installed. Yeah, we already have that installed. A linter. We might not need that. But what I actually wanted to do, so this one has really small downloads. It doesn't tell us what it is. I really don't want to go for it. So we will run the retool, but what we'll do, we'll at least we're going to create us like a script that does it for us. Okay. So what we need to do is we need to create a new. We're gonna make a spike for now, and then I install this this tool. I forgot the name of it already. I hope I wrote it down. And I did not write it down, I suppose, or maybe I wrote it somewhere. All right, Stagehand. So Stagehand is, I'm going to put this also in the resources of the video. Stagehand is a cool tool that allows you to quickly generate Dart. Like, you know, if you have Flutter Create, there's something that you can use for Dart as well. So what we're going to do, we're going to Stagehand, and Stagehand has, we only need console simple. So console full includes testing and also things. We don't need that. So we're going to Stagehand, and I think all you have to do is do that, and it generates everything. Okay, so now we can see we have a spike set up. We have something in the bin folder which we may not need, but what we can do now, we can just open this in IntelliJ, and yep. So this is like what it does right now. Okay, why is it running Flutter? Not sure. But definitely what we can do, we can just run main. Okay, hello world, it works. Yeah, get dependencies. Just, I don't even understand why it's running with Flutter. Fine, not a big deal. Let's look at the pub spec here. It just basically set up this thing, really simple. So really simple pub spec. And now actually we're going to look here. What actually dependencies do we need to pull in? So we need to pull in gRPC, and we need to pull in protobuf. And we may pull in async as well, but we'll see about that. So gRPC, we need to find that on the pub repo to figure out what's the latest version. So gRPC 2.1.3. So let's put that here. And see, like here they were basically just using the gRPC from, because it was part of the example. Oh, so actually I changed it in the wrong. I changed it in the example where I wanted to actually just add it here. Okay, and then we need protobuf. All right, and we'll wait with the async one until we actually run into something where we need it. I just want this. Okay, so this is not working. Let's just do pub get here. All right. And by the way, I apologize if my Twitter handle is right in the way there, but if you want to follow me on Twitter and get updates about future episodes building this game, you should follow me on Twitter. So I just want this to go away. So okay, what we'll do is we'll create a lib folder. Directory where we're gonna put our lib source. I don't know why we have lib source. We just need lib. And so what we're gonna do is we're gonna create a server for now. Well, let's just make it a Dart file. Dart file server. Okay, so the server will have nothing yet. And actually, what we also should do is we should create the protos, right? Protos. Okay, and so we create a new proto file which does not exist. So we create a file. We call it I don't know. It's basically client server, or like message bus, whatever. The proto, right? And so let's look at that, how this is done. So basically what we need is we have a service. What's it called? Game server or game updates. And basically what we want something like an RPC method that looks very similar to the chat one, like this one down here. So we're gonna call this I don't know what you would call this. Updates? I don't know. Or communication? I don't know. I don't even know what you would call this yet. I have a better idea once we see this in Dart code probably. So it returns a stream and it takes a stream. So we take a stream of client update, let's just say, and it returns a stream of it's supposed to be like this, of a game update, right? And so now it's telling us that those don't exist. So we have to create the message client update and the message game update. Okay, and I just want to basically get to the point where we generate something, and then we'll take a break. As always, I will take a around the top of the hour, I will take a break, 5 minutes, and then I'll continue for another hour. So let's look at the client message. So what we could, for instance, include there is, okay, so here we get some, so 32 is actually enough, and we say pressed keys, right? Remember, like in the last episode, we implemented, we changed the way we communicate press keys to just basically use bit flags in one integer. So okay, so it's complaining. What's it complaining? Fields must have labels in Proto 2. Optional, require, or repeated. Oh, because okay. So I think what's going on here, we need to say this syntax is Proto 3, and I'm not pulling anything of like this whole Java stuff in it yet, until I actually know that we need it. So game update. What could the game update be? You're basically going to have to pull out a bunch of things. So for now, I'm going to just say int 32. A number of bullets. Okay. N bullets. Okay, so what we'll do for now, we will really simple spike. We say every time I press a key, the server adds a bullet, and it keeps sending us how many bullets we have. Okay. Is there anything else we need to do here? So where we had the chat. Okay, so did this. I do not know what's the meaning. If we could add something here, there's nothing that we can. I don't understand why it is like this. But there must be a reason. So this is it, I think. What we need to do now is we need to run proto-c on this, and we will create a folder here. We call it generated. And now this should actually be all we need to do in order to generate us some server. So let's see. So I'm gonna do this on the left. I'm gonna look at my history for proto-c. No, hold on. Needs to be grep. So this is the one we used. I mean, basically take that command and modify that. So proto-c dot out gRPC lib. We don't have a source folder, so let's just edit this in Vim. And then the protos are basically the protos, and we called it message bus proto. I mean, there are probably better ways. So now if we quit, it should run it. Okay, proto-c. proc command not found. Okay, that's because we have to export. We have to, and I'm going to put this proc somewhere obviously where it makes sense, and then I'll add this to my path so we don't run into this all the time. Actually, I need to export. Okay, so now we should be good. All right, cool. Now let's see what happened here. So we have generated, so we have a message bus, client update. Okay, cool. And so in here we should have the services. So we have game updates client, and we have a game updates servers base. Okay, and so what we need to do next is we need to write our server to use it. But at this point, we will take this break that I was talking about,